This last section of our chapter on polynomials has to do with dividing polynomials, but we're going to limit our division to dividing a polynomial by a monomial, meaning one term in the denominator. So let's take a look at how you do this, and rather than looking at our general rule here, I'm just going to show you through example. So here I have a polynomial, 6m squared plus 2m, being divided by 2m. So the first step is to rewrite that as division in fraction form. So we want to see our polynomial looking like a fraction. The second step is to then take the terms of the numerator and we're going to split them. In this case, there are two terms in the numerator, so we're going to split it into two smaller fractions. The first one is going to be that fraction, so 6m squared over 2m. Then I put my plus sign. And the second one is going to be this piece, the second term of the numerator, over that same common denominator. And now all that is required is to cross cancel within each of our individual fractions. So 2 goes into 2 once, it goes into 6 3 times. This m cross cancels one of those, leaving 1. So in my first term I have 3 times m over 1, which is just 3m. Here 2 goes into 2 once, m goes into m once, and I'm left with just 1. So I do the division by splitting my fraction into the pieces determined by how many terms are in the numerator. So let's do another one. This would be 25x to the fourth over 35x squared. Then we put plus 5x cubed over 35x squared. So we have our two fractions. Notice denominators are the same. All right, they have that same common denominator. Now we cross cancel. What goes into 25 and 35? That would be 5. So it goes in 5 times here, 7 here. These two x's cross cancel 2 of those. And so my first term is a 5x squared over 7. 5x squared over 7. Here, 5 goes into 5 once, it goes into 35 7 times. These two x's cross cancel 2 of those, and you're left with 1x over 7. You can or cannot show that one up, it's up to you. Now in this case, I can leave this as my answer, but because those two pieces have the same denominator, I could put it back together if I wanted in one fraction, 5x squared plus x over 7. All right, let's look at the next one. This time my numerator has 1, 2, 3 terms, so I'm going to split my fraction into 3 pieces. So 9x to the fifth over 3x squared minus 12x squared over 3x squared, that's an x there, and plus 3x over 3x squared. So they all share that same common denominator. Now there's something a little tricky about this one, so watch carefully. 3 goes into 3 once, it goes into 9 3 times. X squared cross cancels 2 of those, leaving 3. So my first piece that's left is a 3x cubed. 3 goes into 12 4 times, into 3 1 time. The x squareds cancel each other, so it's just a 4. Now here's the part that's tricky. 3 goes into 3 once, but where do you have more x's? You have more x's in the denominator. So this 1x cross cancels one of those, leaving an x, but look where it is. It's in the denominator. So it's 1 over x. So it's 3x cubed minus 4 plus 1 over x. And that's not the same thing than if you just said there was an x left over. It's 1 over x. All right, let's try this one. Again, we're going to split it into 3 fractions. So, oops, not 4. 8x squared y squared over my denominator minus 16xy over my same denominator plus 2x over the same denominator. And again, you've got to be really careful with your cross-canceling here. 4 goes into 4 once, it goes into 8 twice. This x cross-cancels one of those. This y cross-cancels one of those. Notice how I cross out what's used up. So I'm left with a 2xy in my first term. 4 goes into 4 once, it goes into 16 4 times. X cross cancels x, y cross cancels y, and I just have a 4 there. Here, 2 goes into 2 once, it goes into 4 twice. Look where the 2 is, it's in the denominator. X cross cancels x, y is left. But what's left in that numerator? A 1. So I have a 1 over 2y. Be careful, the whole thing isn't over 2y, just the last term. So really make sure that when you cross cancel, that what is left stays where it's left. The y and the 2 were left in the denominator, that's where they remained.